So this is 5.6 related rates.
Is this the last section in this chapter?
Yep.
Okay. Are we quizzing or straight to test?
I think we'll quiz first because sometimes people need a reality check on, do I really know this stuff?
Yeah.
Especially this particular section.
Yeah.
Be like, I got it, and then they get there and they're like, oh, I don't got it.
Oh, yeah.
It's better to find out in a quiz.
Exactly.
All right, so for problems 1 through 41, assume all variables are differentiable functions of t. So basically, when we take the derivative, everything is going to be with respect to t.
With respect to t.
So surface area, the radius r, and surface area s.
Oh, do we write this in our notes?
I mean, you can. I'm just copying the problem so it's on the board so that people can actually see what's happening, but are related by the equation s equals 4 pi r squared. Write an equation that relates ds dt to dr dt. So essentially this is like implicitly differentiating everything because everything is with respect to time.
Okay.
So everything is a variable that we're taking with respect to t. So when we take the derivative of this, the derivative of s is going to be ds dt. And then on the other side over here, we take the derivative with respect to t of r, and so that's going to end up being 8 pi r dr dt. So this is like when we did like the y primes for implicit, but we just wrote it, we didn't write it as like dy dx, we wrote it as just y prime. And so like the word problems then would tell you potentially some different things about this, and you would end up solving for whatever piece you're missing. So like you might end up solving for surface, like for ds dt, and you end up having r and dr dt, and you just have to use that to solve for ds dt. It's kind of like what. So basically right now we're just showing like how to find that like first step of like the derivative, and then when we get into the word problems, they'll be giving us things to plug in.
Okay.
Or a picture that we pull information from to plug in, kind of thing. Let's see. 4 has 2 parts. Okay, it says the power P in watts of an electrical circuit is related to the circuit's resistance R in ohms and current I in amps by the equation P equals RI squared. I'm not writing the whole problem for that one. So then part A says, how is dP dt related to dr dt and di dt. So I'm going to rewrite this. So we're taking the derivative, again, with respect to t. So on the left side, we've got dp dt. Huh?
I'm already making some apple juice.
I kindly pass.
Y'all and that apple. Oh my goodness.
Literally.
All right, so
Baby.
What?
what?
She was a baby?
If it got dropped.
I thought he said he was having a baby, and I was really confused.
Nathan has a lot of things to explain.
That was- yeah, a lot. Okay, so
You're recording, aren't you?
so R and I, okay, those are being multiplied. So when I take the derivative, what might I need to do?
Chain product.
Yes, the product rule.
I always get those mixed up.
So the first times the derivative of the second, or it doesn't really matter what order, but first, so R times the derivative of the second is going to be,
2i.
2i di dt plus the derivative of the first, dr dt, times the second, I squared. So just to make this look a little nicer, dp dt is equal to 2i r di dt.
So where did the di dt and dr dt come from when you were taking the derivative of ri squared?
The implicit part of, because I'm taking the derivative with respect to t.
Like, you know how we would have to put y part of that at the end?
It's like, yeah, it's
basically
like r prime, but we're writing it with respect to t so that we know that
Yeah.
what we're taking it. And then plus I squared dr dt. Then part B, how is keep writing it backwards, dr dt related to di dt if p is constant? So I start with the same equation. So p is constant. So if I take the derivative of p, what is that then? If it's a constant.
0?
0.
I can't not see it as a very
Yeah. So then I have the same product rule that I had up here. So I'm just gonna copy it down because I'd already done it up here.
Yeah.
Okay, so that's where it's coming from. So 2ir di dt plus I squared dr dt. So now I want to relate them to each other, so I'm going to move one of them over. Or what says how is dr dt related to di dt, so I'm going to move the dr dt to the left to get it by itself. So minus I squared dr dt equals 2ir di dt then we divide by I squared, or negative I squared, so dr dt is equal to negative 2, the I is going to cancel on the top, so it'll be gone, and then on the bottom I'll just be left with the I, so 2r over I di dt, and don't forget the negative out front. So because it wants dr dt related to the other one, that's what comes first, so that's like what we solve for by itself, basically. All right, let's see. One more. Number 8. Heating a plate. When a circular plate of metal is heated in an oven, The radius increases at a rate of 0.01 centimeters per second. At what rate is the plate's area increasing when the radius is 50 centimeters? So this is actually kind of like an easier related rate problem, like an intro related rate type problem. So they tell us that the radius is changing at a rate of 0.01 centimeters per second. So that is going to be dr dt. At what rate is the plate's area increasing when the radius is 50 centimeters? That means R is 50 centimeters. And they want to know at what rate the area is increasing at, so that's going to be what we call dA dt. So if I have a circular plate, the first thing I want to start out with is a formula, okay? So I'm thinking, what am I looking for? I'm looking for area, and I know I'm dealing with a circular plate, so I'm going to want the area of a circle. So what is the area of a circle? A equals pi r squared. So then I take the derivative
2 pi r
times.
dr
Yep. So dA dt is equal to 2 pi r dr dt. So now we have what we're trying to solve for over here by itself. So I take the givens that were given to me in the problem and I plug them in. So dA dt equals 2 pi times 50 times 0.01 . And that actually nicely ends up canceling and just leaves you with pi centimeters squared per second. That's probably the hardest thing, is going to be remembering units. Okay, because all related rate problems have to have units. Okay, so this is the rate that the area is changing at. It's changing at pi centimeters squared per second. And so that's how we would go about doing that. So we'll save the rest of those for after we do the worksheet, but that way you have a little bit of an intro of what's coming kind of thing. And that way they didn't miss too much.
So basically you learn how to like set the problems up.
Basically, yeah.
Okay.
These kind of gave you more information than some of them will.